Now I am going to discuss the advantages and disadvantages of half-wave rectifiers. That is, what are the advantages of half-wave rectifiers and what are the disadvantages of half-wave rectifiers also. In previous classes we already discussed what is the half-wave rectifier. What is the working principle of half-wave rectifier, how it will be converted from AC to DC also. So now what are the advantages of half-wave rectifier means, see here, in case of half-wave rectifier we are using only one diode. So the first point is the half-wave rectifier is a simple circuit because we are using only one diode. That's why the half-wave rectifier is a simple circuit. Second point, it has a low cost. Means we are using only one diode. So the cost of the rectifier, half-wave rectifier circuit is very less as compared to other rectifiers, because the other center tap bridge rectifiers and bridge type rectifiers using more than one diode. The center tap rectifier using two diodes and the bridge type rectifier using four diodes. As compared to that full wave rectifier, this half wave rectifier is using only one diode, so it has low cost. Next point, we can easy to use it because the circuit is very simple, so we can easy to use this half wave rectifier. Next point, we can easily construct. Means we are using the less number of components in half wave rectifier as compared to other rectifiers, full wave rectifier. So the construction view, it is very simple. We can easily construct the half wave rectifier. It has one transformer, one diode and one resistive load. Only three components it consists. So the construction of half wave rectifier is very easy or simple. Next point, it has a low number of components. Therefore it is cheap. It has a low number of components means we are using only one diode, one transformer, one resistive load. So the cost of the half wave rectifier is very cheap. That's why it has low number of components and therefore it is very cheap. These are the advantages of half wave rectifiers. 4 points. Half wave rectifier is a simple circuit. It has a low cost. We can easy to use it. We can easily construct. It has low number of components. Therefore, it is cheap. This is the advantages of half wave rectifier. Next, we will discuss what are the disadvantages of half wave rectifier. Every electrical component, every electronic components has advantages and disadvantages also. Like that, this half wave rectifier also has the disadvantages. So first, the transformer utilization factor is very low. Because we are taking only one half cycle. Second point, they produce a low output voltage. See here, the output side will produce only one half cycle voltage, because during a half wave rectifier, in a positive half cycle, the diode will be act as a forward bias and it will be conduct the flow of current. During negative half cycle, the diode will be act as a reverse bias. In reverse bias condition, the diode doesn't allow any flow of electric current through diode. So we are using only positive half cycle. We are blocking the negative half cycle. Simply, that is, when the diode will be forward bias condition, it will be conducting. When the diode will be reverse bias condition, it will be blocking. Okay, so here the diode will be forward bias condition in only one cycle. In the remaining cycle, it will be reverse bias condition. In one half cycle, it will be forward bias condition, and remaining half cycle, it will be reverse bias condition. So in forward bias condition only, it will be allow the flow of electric current or voltage. Okay, so they produce a low output voltage. That's why it will be produce very low output voltage. Only 50% of the input voltage will be converted to the output side. Remaining 50%, the 50% of the voltage in positive half cycle and 50% of the voltage is negative half cycle. So this half wave rectifier always converts only one half cycle. So we are utilizing only 50% of the half cycles. That's why they produce a low output voltage. Third point, the power output is low, and therefore the rectification efficiency also quite low. So the rectification efficiency is quite low, 40.6 only, and the ripple factor is high, and elaborate filtering is therefore required a given steady DC output voltage. Therefore required to give a steady DC output voltage, it will be provide the steady constant DC output voltage. The rectification efficiency is very less. The rectification efficiency is very less as compared to other diodes. So here next the fourth point, they only allow a half cycle through per sine wave. They only allow a half cycle through per sine wave, and other half cycle is wasted. This leads to power loss. They only allow a half cycle through per sine wave, and other half cycle is wasted. This leads to power loss. So here this point, they only allow a half cycle. It will be allow a half cycle through per sine wave. In sine wave it will be allow only half cycle, that is positive half cycle, and other half cycle is wasted. This leads to the power loss. With help of one more half cycle, it will be leads to the power loss. Okay, these are the disadvantages of half wave rectifiers. These are the disadvantages of half wave rectifiers. Next some problems on half wave rectifiers. See here the first problem, the applied input AC power to half wave rectifier is 100 watts. The applied input AC power to a half wave rectifier is 100 watts. The DC output power obtained is 40 watts. First one, what is the rectification efficiency? What happened to the remaining 60 watts? See here, all of you clearly observe this problem. The applied input AC power to half wave rectifier is 100 watts. Okay, we are applying input AC power is 100 watts. The DC output power obtained is 40 watts. The remaining 60 watts will be loss. So what is the rectification efficiency? What happened to the remaining 60 watts? See here the rectification efficiency. In this problem, what is the definition of rectification efficiency? The rectification efficiency is DC output power by AC input power of rectifier. Okay, DC output power by AC input power of the rectifier, because in output side of the rectifier it will be available the DC output, and input side we will be given to the AC. So the rectification efficiency, it is the ratio of DC output power by AC input power. In the given problem, the output watts is 40 and the input power is 100. So 40 by 100 into 0.4. The rectification efficiency is 0.4, and the rectification efficiency percentage is only 40%. Remaining 60%, what happened? The remaining 60%. See here the 40% efficiency of rectification does not mean the 40% efficiency of rectification does not mean that 60% of power is lost in rectifier circuit. 40% efficiency of, see here, the rectification efficiency is only 40%. So the 40% efficiency of rectification does not mean that 60% of power is lost in the rectifier circuit. In fact, a crystal diode like PN junction diode consume little power. The diode also has some consume little power due to its small internal resistance. So each electrical component has their internal resistance. Due to that internal resistance, some losses will be occurred in each electrical components. Like that, the diode consumes a little power due to its small internal resistance. The diode also has some internal resistance. Due to that internal resistance, some losses will be happen. So the 100 watt AC power is contained as 50 watts in positive half cycle. This is the most important. How its rectification efficiency is only 40% means, see here the loss only 60, not only loss 60. Here the losses of the efficiency is only 50. See here the 100 watts AC power is contained as 50 watts in positive half cycle and 50 watts in negative half cycles, because with help of half wave rectifier we will convert only one half cycle. That one half cycle contain 50% of watts only. Remaining half cycle will be blocked in case of half wave rectifier. So remaining the negative half cycle or positive half cycle also containing the 50 watts. So the 100 watts AC power is contained here, 50 watts in positive half cycle and 50 watts in negative half cycles. So the 50 watts in negative half cycle are not supplied at all. See here, the 50 watts in the negative half cycle are not supplied at all, either positive half cycle or negative half cycle. Each half cycle containing 15 watts. So with the help of this half wave rectifier we are converting only one half wave from AC to DC. So the 50 watts in negative half cycle are not supplied at all. Only 50 watts in positive half cycles are converted into 40 watts. That means at overall only we are using 50% of the power. Remaining 50% of the power we are not using, because with help of half wave rectifier we are converting only one half cycle. That is only 50% of the half cycle we are converting. So the 50 watts in negative half cycle are not supplied at all. Only 50 watts in the positive half cycle are converted into 40 watts. Although 100 watts of AC power was supplied, even though 100 watts of AC power supplied to the half wave rectifier, a half wave rectifier is accepted only 50 watts, and converted it into 40 watts DC power and converted it into 40 watts DC power. Therefore, it is approximately to say that efficiency of rectification is 40% and not 80%. See here, it is approximately to say that the efficiency of rectification is 40% and not 80%, which is power efficiency. Okay, so here the majority of the disadvantage is, with help of this half wave rectifier we are converting only one half cycle, that is the negative of as compared to other rectifiers. So the rectification efficiency is only 40% or 40.6%, because we are using only positive half cycle. All negative half cycles were blocked in case of half wave rectifier. Okay, that's why there are in disadvantages. This rectifier has the number of disadvantages also and advantages also. When we are going to only one diode, it has a simple circuit, low cost, easy maintenance, easy construction. This is the advantage, and this is the disadvantage also applicable. In next class I will discuss the number of more problems. Okay, thank you.